Hi, my name is Patrick Reagan. This video, Troubleshooting Basics Part 2, looks at other topics including using the OSI model to troubleshoot problems. The OSI model provides a structured approach to network troubleshooting by breaking down communications into 7 layers. Examining the OSI model for troubleshooting is part of establishing a theory of probable cause. By analyzing issues layer by layer, you can isolate the root cause efficiently. Utilize networking diagnostic tools like ipconfig or ifconfig, ping, traceroute, and nslookup to verify configuration, test connectivity, and test DNS. Use protocol analyzers such as Wireshark to analyze traffic and identify issues. You can see from the table that physical layers covers hardware and cables, while Layer 2 covers MAC addressing and switching. Layer 3 covers routing and IP addressing. Layer 4 covers reliable data delivery. Layer 5 covers connections and authentication, while Layer 6 covers data format and encryption. Lastly, Layer 7 covers software and user access. For the physical layer, Layer 1, check if the network cable is connected and there's no obvious damage. Verify if the network adapter is enabled. Look at the router modem indicator lights. Make sure that the network devices such as routers, switches, and NICs are powered on and functioning. Try using different cables, network ports, or network devices to rule out hardware failure. For the data link layer, Layer 2, check if the device is receiving an IP address using the ipconfig/all or ifconfig command. Make sure there are no conflicts or incorrect MAC address configurations. Look for MAC address filtering or VLAN issues. Make sure the switch port is enabled. Ensure that NICs are working correctly and drivers are up to date. Swap out network devices to see if the issue persists. For the network layer, Layer 3, verify that the IP addresses are correctly assigned and there are no conflicts. Check for correct subnet mask and default gateway. Use ping commands to check connectivity between devices, including pinging the default gateway. Use traceroute to test the path to an external website. Ensure that the routing tables are correctly configured and routers are functioning. Make sure the DHCP server is up and running. For the transport layer, Layer 4, verify that the correct ports and protocols are being used. Make sure you don't have 2 applications or services using the same TCP/IP or UDP port on the same host. Check if TCP or UDP ports are blocked by a firewall. Use netstat to see open and listening ports. Use tools like traceroute to check the reliability and latency of the connection. For the session layer, Layer 5, verify authentication and login credentials. Check if the VPN or remote session is timing out. Ensure that the sessions are being properly established, maintained, and terminated. Look for errors in application logs that may indicate session issues. For presentation layer, Layer 6, check for SSL and TLS encryption errors, including invalid certificates or expired certificates. Confirm file format compatibility. For application layer, Layer 7, test the web browser, DNS settings, and application logs. Check proxy settings. Restart the application or clear cache. Make sure the application settings are correct and there are no configuration errors. Verify that users have the necessary permissions and access rights. Use performance monitoring tools to identify any application-specific issues. When using the OSI model, you can use a top-to-bottom approach, use a bottom-to-top approach, or start in the middle of the OSI model and go up or down the OSI model based on the findings of the middle layer. Use a top-to-bottom approach when the issue is specific to an application, such as web browser not loading or email not sending. Other network services are working, but one app or service fails. There are DNS, HTTPS, or authentication problems. User can access the network but experience performance problems such as slow websites or buffering video. Use a bottom-to-top approach when devices are not connected to the network There are physical connectivity issues such as faulty cables, unplugged devices, or NIC failures. There's no signal, no link lights, or slow network speeds. Or pinging and IP fails, suggesting lower layer issues. You would start in the middle of the OSI model when you're unsure if the issue is caused by network connectivity or application failure. A top-to-bottom approach in network troubleshooting using the OSI model means starting at the application layer, the highest layer, and working your way down through the layers, checking each one progressively until you identify the source of the network issue. You begin troubleshooting by examining the application that the user is trying to access, such as web browsers or email clients, which operates at the application layer. If the application shows issues, you then move down to the presentation layer, then the session layer, and so on until you reach the physical layer. This method helps isolate the problem by systematically checking each layer, allowing you to pinpoint the exact location of the network failure. For example, a user complains that email is not sending, but they can browse the internet. If the user is the only one experiencing the problem, you can rule out that there's a problem with the email services being down. You'll then start by checking the email client in the email settings for the email application, such as SMTP settings. You'll then look at the firewall rules, including any firewalls running on the client, and work down to network connectivity. A bottom-to-top approach when troubleshooting using the OSI model means starting at the physical layer, the lowest layer, and systematically working your way up through each layer of the model to identify the source of the network issue, checking each layer for potential problems before moving to the next higher one. Essentially, focusing on the most basic hardware components first and gradually progressing to more complex application level functionalities. You start at the physical layer that deals with the physical connections like cables, connectors, and electrical signals, making it the logical starting points for troubleshooting. Once you verify the physical layer functions correctly, you move to the data link layer, then the network layer, and so on, checking for each issues at each level before moving up. By systematically checking each layer, you can isolate the problem to a specific part of the network communication process, making it easier to pinpoint the root cause. For example, a user reports that they can't connect to the internet. You start by checking the Ethernet cable, then the switch, then IP settings, and finally DNS resolution. You'll then move up to the transport layer to check TCP, UDP ports, and firewalls. You'll then move to the upper layers. Instead of starting from the top or application layer, or bottom physical layer of the OSI model, you start somewhere in the middle, often at layer 3 network layer, by testing IP connectivity using the ping or trace route. Based on the results from the network layer, you move up the OSI model layers, or you move down and continue troubleshooting in the appropriate direction. To test the network layer, use ping, traceroute, and NSLOOKUP to test IP connectivity and move up or down based on the results. If ping fails, the problem is with layer 3 or lower. Therefore, you'll need to check routing, MAC addresses, VLAN, switches, Wi-Fi, and physical components. If ping succeeds, the problem is above layer 3, the transport, session, and application. Since the network is working, check transport and application layers such as firewalls, ports, DNS, and applications. The divide and conquer method involves breaking down a complex problem into smaller, more manageable parts and systematically testing each section to isolate the root cause of the issue, like checking the user's internet connection, DNS resolution, firewall settings, and the website server itself, isolating the problem by testing each part until you identify the root cause of the inaccessibility. Key points include: ask targeted questions which will gather information from the user about their specific situation, like if the issue is occurring only on their device, on a specific network, or for all websites. Prioritize checks by starting with the simple checks like network connectivity and gradually moving towards more complex troubleshooting steps. Document your findings, including keeping track of the steps taken and the results of each test to facilitate future troubleshooting efforts. You can also use divide and conquer when you have multiple potential underlying causes for the global system outages and you tackle one at a time, or you assign an area to troubleshoot to different team members. When you divide the problem, start with the basic checks. Connectivity, which will verify if the user has a working internet connection by trying to access other websites. Browser issues, check if the problem occurs in different browsers or if the user has outdated browser settings. Website address ensures the user is entering the correct website address with proper spelling and capitalization. For the network layer, DNS resolution uses command line tools like NSLOOKUP to check if the website domain name resolves to a valid IP address. The ping test will test the network connectivity to the website server using a ping command to see if packets are reaching the server. For the application layer, firewall security settings will check if the user's firewall or security software is blocking access to the website. Cookies and cache will clear the browser cache and cookies to eliminate potential conflicts. You would then conquer the subproblems. Based on the initial checks, narrow down the potential problem area, such as the user's network, DNS settings, or the website server itself. For further investigation, if the issue seems network related, use tools like traceroute to identify potential bottlenecks in the network path to the website server. For server status, you can check if the website server is currently experiencing downtime using external website monitoring services. For website-specific checks, you can check if the issue appears to be website-specific, check for any known issues or maintenance on the website. You would then combine the solutions. Implement fixes. Based on the identifying cause, implement the necessary adjustments like changing network settings, clearing browser cache, contacting the website administrator about server issues, or addressing firewall rules. For verification, retest the website access to ensure the problem has been resolved and the user can now access the site properly. In troubleshooting, a root cause refers to the fundamental underlying reason or issue that is causing a problem, essentially the why behind the symptom or malfunction, allowing you to address the problem as its source rather than just treating the visible effects. Essentially, it's the practice of digging deeper to find the core issue rather than just treating surface-level symptoms. Asking why repeatedly to peel back layers of contributing factors. The 5 whys is a simple problem-solving technique where you repeatedly ask why about a problem up to 5 times to progressively delve deeper and uncover the root cause of the issue, which is a method to identify the fundamental reason behind a problem by systematically exploring the chain of events leading to it. To identify the root cause, you need to perform a root cause analysis, or RCA, process where you systematically investigate the problem by asking why repeatedly to uncover the primary cause. It is important to address the root cause because fixing only the immediate symptoms without addressing the root cause can lead to recurring problems in the future. For example, if a computer is not turning on, a superficial cause might be a dead battery, but the root cause could be a faulty power adapter that is not charging the battery properly. Another example would be the computer keeps crashing. While the surface level solution is restarting the computer, you'll need to investigate further to find the root cause, which could be a failing hard drive, overheating components, or outdated software causing conflicts. This slide discusses what I call the body check. While the body check is not an established methodology, it is something I keep in mind when I'm troubleshooting problems, and it's just something I use to emphasize certain points. Body is short for backup, obvious, duplicate, isolate. Backup is the first part of the body check. When you're troubleshooting a problem, you need to consider the risk to data, and if possible and reasonable, you should make sure you have a backup of the data in case the problem gets worse before it gets better. Unfortunately, when many problems occur, it is often too late to get a backup of the data. So hopefully for your organization, you have a backup process put in place that protects essential data. The other three parts of the body check were already discussed with the CompTIA troubleshooting steps. Make sure you check the obvious because obvious is the simple things that are often overlooked. To troubleshoot a problem, you have to duplicate the problem and confirm that the problem actually exists. Lastly, you need to isolate the problem, including determining the extent of the problem. When troubleshooting, don't make assumptions. Instead, verify. For example, you might assume that the computer is plugged into the electrical outlet. Since you might assume that the computer is plugged in, you do not check the obvious. Lastly, make sure that you communicate. As you work with a user with a problem, make sure the user is kept informed of your progress. If you're going to make changes to his or her system that may affect how the user uses the system, or that there will be delay in fixing the system, be sure to communicate that to the user. While you're troubleshooting problems, you need to set expectations with those affected by the problem. Troubleshooting problems can be very frustrating at times, and it can take a lot out of you. You need to be rested, and you need to keep a clear mind. You need to avoid making it personal. If things start to get frustrating, be sure to take a deep breath, and if necessary, take a step back. This may consist of taking a break or jump to something else to get your mind off of it. If your knowledge-based internet searches do not provide the necessary help that you need, don't be afraid to ask for help. Talk to your peers and escalate to the necessary specialized teams. Also consider opening a ticket with the appropriate vendor. You need to start gathering best practices and recommended settings for computers, devices, and software and put that information into a repository. You also need to make plans to follow the best practices and recommended settings when it makes sense. Following best practices will help you avoid problems now and in the future. In addition, when selecting, installing, configuring computer components, and software, you should consider defining standardizations within your organization. You should consider that each user uses the same type of computer and same type of software. By standardization, you'll reduce variance, reduce the burden of IT staff, avoid compatibility problems, and improve communications. One type of standard is the de facto standard, which is a standard that has been widely accepted by the industry and customers, but has not undergone any formal process to obtain consensus. Some common de facto standards are the use of the QWERTY keyboard and the Windows operating system used in enterprise organizations. Question: you verified that the computer is connected to a surge protector that is connected to an AC outlet. You replace the surge protector, the computer, the monitor, and the printer, yet you cannot get the computer to turn on. After a couple of hours, you realize that the AC wall jack is connected to an on-off wall switch. What did you forget to check? Answer: the obvious. Make sure you check the obvious because obvious is simple things that are often overlooked. Question: the user is experiencing global system outages. You have identified multiple potential underlying causes throughout the enterprise. Each team member has been assigned an area to troubleshoot. Which of the following approaches is being used? Answer: divide and conquer. Question: you have a user that is not connecting to a network. Which approach should you try? Answer: bottom to top. Question: which of the following steps of the troubleshooting methodology would most likely include checking throughout each level of the OSI model after the problem has been identified? Answer: establish a theory. For more information, refer to these sites. In summary, make sure you check the obvious because obvious is the simple things that are often overlooked. It is possible that you can encounter multiple problems at the same time. If you determine if there are multiple problems, you need to approach one problem at a time. A top-to-bottom approach in network troubleshooting using the OSI model means starting at the application layer, the highest layer, and working your way down through the layers, checking each one progressively until you identify the source of the network issues. A bottom-to-top approach when troubleshooting using the OSI model means starting at the physical layer, the lowest layer, and systematically working your way up through each layer of the model to identify the source of the network issue, checking each layer for potential problems before moving to the next higher one. The divide and conquer method involves breaking down a complex problem into smaller, more manageable parts and systematically testing each section to isolate the root cause of the issue. Thank you for watching this video. This completes the Networking Concepts series. The next series will be Basic Networking Hardware. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.